Hello friends. In this video, we are going to study about the Transcendental Instructions present in 8087 Math Coprocessor. The instruction set of 8087 is classified into different categories, and out of these 6 categories, there is one category of instructions called the Transcendental Instructions, which are also called the Trigonometric and Exponential Instructions. So let's start with our topic. The 8087 coprocessor, it is the first math coprocessor which was developed by Intel to pair with the 8086 and 8088 microprocessor family. Okay, so this coprocessor, it is used to perform very high speed calculations and also the calculation which involves very large numbers or very short numbers or the floating point numbers. Okay, so this 8087 coprocessor, it has its own architecture and its own instruction set. Okay, now the instruction set of 8087, it is categorized into different classes. Okay, let's see that how it is classified. Data transfer instructions, arithmetic instructions, compare instructions, transcendental instructions, load constant instructions, and processor controlled instructions. Depending upon the function and the operation performed by these instructions, they are classified into these 6 categories. Now, all the instructions present in the 8087, their mnemonics will start with the alphabet F. So all the instructions, they will have F as its prefix or its starting alphabet. Now here this F, it starts for the floating point numbers. Okay, so when we see the instructions of 8087, every instruction will have its starting alphabet as F. Okay, now let's start with the transcendental instructions, which are also called the trigonometric and exponential instructions. The first instruction in this category is F P T A N. What this instruction does? So this instruction is going to compute the values or calculate the values for the ratio y by x. And this ratio values, they are calculated for an angle in ST. Okay, so in ST we are having the value of the angle, and for that angle the ratio y by x is calculated. Okay, now the value of this angle must be in the range (0 and pi by 4). means angle should be greater than 0 and less than pi by 4. Then the angle values between this range that is used here and the ratio is calculated. Now this instruction FPTAN, this instruction is not going to give the correct values for the angle 0 and for angle pi by 4. That is why the range for the angle is given as greater than 0 and less than pi by 4, not equal to. Okay, so angle, when angle is equal to 0 or it is equal to pi by 4, then this instruction will not give correct values. Incorrect values are given. So range is specified that angle should be greater than 0 and less than pi by 4. In that range only the ratio y by x is calculated. Okay. Now here this angle which is specified in the ST. ST is the top of the stack. Okay, the register from where the stack is starting, that is called ST, where the stack pointer is pointing. Okay, now this angle, it should be expressed in radians. Okay, so this was the first instruction, FPTAN. AN is for the angle. Okay, now next instruction is FPATAN. You can see that in these instructions, no source, no destination is specified. So the operand is implicit only, that is present in ST, that is top of the stack. Okay, no other operand is to be specified in the instruction. FPATN, what this instruction is going to do? This instruction also computes the angle whose tangent is y by x. Okay, now this instruction is going to calculate the angle. Okay, and the angle whose tangent is given by y by x. Now this y and x, they are specified as x is given in ST and y is present at ST1. Okay, so from here we can get the values of x and y, we can calculate this ratio and then we can calculate the angle. Okay, now x and y, their range should also be, the x and y, they must satisfy this inequality. So this x and y, they must satisfy this inequality. Now when this ratio, that is y by x, is calculated, for this ratio angle is calculated. So this angle is stored at ST1, means it is going to replace the y. Y is replaced by this. Okay, so in the stack, suppose this is the stack. So in stack at ST we are having x, at ST1 we are having the angle. Okay, now after this, because angle has replaced the y in the stack, now after this operation the stack pointer is incremented. Okay, so that is the difference between the earlier instruction, that is FPTAN and FPATAN. Okay, the difference is that in the earlier we were calculating the tangent ratio, that is y by x. In this the angle is calculated. Okay, and also additionally the stack pointer is incremented in this instruction. So overall, what this instruction does, it computes the angle and store that result at the position ST1. And after this operation, stack pointer is incremented. Now next instruction is F2XMI. Okay. Earlier two instructions were the trigonometric instructions. Now we are having the exponential instruction. What this instruction does, it computes the function y equals to 2 raised to the power x minus 1. Okay, means 2 exponential x minus 1 is calculated, and that is stored, means that y value is calculated, and result is stored in ST. Now this x value that is earlier present at x, okay, the processor, it computes the function y equals to 2 raised to the power x minus 1, that is calculated, and the result is stored in ST. So x is replaced, okay, x is replaced by the function y, okay. Now this x is must be in the range greater than equals to 0 and less than equals to 0.5. That is the range for the value of x. Okay, so this is the instruction F2XMI. Okay, that means 2 raised to the power x minus 1. Okay, 2 raised to the power x minus 1 is done here. Okay, now next instruction is FYL2x. Okay, that is also an exponential instruction. This instruction is going to calculate y times the log to the base 2 of x. You can see in the instruction y times log to the base 2 of x. Okay, that y times L is for the log 2 and then x is the value. Now here what we are calculating, y is what, log to the base 2 x, means this function we are calculating. Earlier we are calculating y equals to 2 raised to the power x minus 1. Now we are calculating y equals to log to the base 2 x. Now here also the range for the value of x is decided. X is less than infinity, greater than 0. And y, its range is also decided. Y should be less than plus infinity and greater than minus infinity. So for here x and y, their ranges is already decided. Now in these instructions, the x is this stored in ST and y is in ST1. Okay, so in this instruction, x was stored at ST and y, it is replacing the x and it is stored at ST. In this instruction, x is stored in ST and y is stored at ST1. Okay, that is also one difference between the two. After this instruction, the stack is popped. Stack is popped means the stack pointer is incremented by 1. Okay, that is FYL2X instruction. Next instruction is Fy L2x Pi. Again, it is going to compute the y times log to the base 2 of x plus 1. Okay. Earlier it was only x was there. Okay. Now additional is plus 1. That is x plus 1, and that base, that log is going to be calculated. It is going to compute the function y times log to the base 2 of x plus 1. That means y is equal to, that is being calculated. Now here, this is also identical to the earlier instruction, except that here x plus 1 is used. Okay. So this instruction, it is generally used because it gives accurate results when we are computing the log of a number which is very close to 1. Okay, so that is the speciality of this instruction, that it gives us accurate results when we are calculating log of a number which is close to 1. So these are the exponential and the trigonometric instructions present in the 8087 coprocessor. Let's summarize these instructions. So we studied the instructions F, P, T, A, N and F, P, A, T, A, N. First instruction was calculating the ratio y by x for an angle. And second instruction is calculating the angle for y by x. Next we studied F2x mi, Fy L2x and Fy L2x plus 1. Okay, so here these instructions are for the exponential instructions. It calculates 2 raised to the power x minus 1. It calculates log to the base 2x, and it calculates log to the base 2x minus plus 1. So these are the exponential instructions, and these are the trigonometric instructions, will calculate the angle and the exponent values, functions. Okay. So this completes the Transcendental Instructions in the 8087 math coprocessor. So I hope that this topic is now clear to you. Thank you.